Okay, we'll get started. In this section, we're going to be looking at 5A and 5B. So types of energy, and then we're also going to be looking at two types of energy a little more specifically. So the first idea here is, what is energy? Energy is kind of hard to define, but we're going to say energy is the ability to do work. So we're going to say energy is the ability to do work. So it's kind of, when you see it. Like, for example, the sun has the ability to do work. It has the ability to move water. It has the ability to heat stuff up. So we say it has energy in it, basically. People, right, can move around, can move other objects. We could say they have energy, they do work. A car with gasoline in it, has energy. It has the ability to do work or useful tasks. So that's kind of the definition of energy. Energy is a scalar, meaning it has no direction, only size. And it has the standard metric unit of joules, abbreviated J. So if you see like 5J, that stands for 5 joules of energy. There are several different types of energy. We're going to be going through them in this table. There are others, but these are the ones we're going to focus on the most. So the first type of energy is kinetic. It's going to have the symbol K. And kinetic energy is the motion, or it's the energy of motion, but of everyday objects. Meaning not like molecules or atoms. It's the motion of, if you push a shopping cart, if you roll a ball, those things, those physical things that you can see moving, they're all going to have some kinetic energy. The next type of energy is thermal. So the next type of energy is thermal energy. Thermal. And it is going to be energy due to temperature. So if something has an elevated temperature, it's going to have thermal energy. So a good example is a candle, a heater. So anything like that is going to have thermal energy. The next one is electrical. Electrical energy. So that is energy due to the flow of electricity. So if you have electricity flowing, you're going to say it has electrical energy. So some examples might be a light bulb, Xbox, anything electronic. So anything that runs on electricity, you'd say has electrical energy. The next four are all going to have something in common. They're all going to be types of energy, but they're going to be types of potential energy. Meaning that potential energy is a type of energy that is stored, basically, in an object that can be released later. So the first type is going to be gravitational potential. So gravitational potential, that's energy stored because something is an elevated position. So for example, house on a tall hill, book on a tall shelf. Anything elevated above ground level is going to have some potential energy that could be released if that thing were to fall. The next one, it got a little split here, is energy stored in a springy or stretchy object, and that's going to be called elastic potential. Elastic potential. I'm just going to write elastic P for potential instead of writing out potential every single time. So elastic potential energy. That's energy stored in a springy or stretchy object. And that example is like if you have a Nerf gun, if you have a rubber band, anything that stretches and then can later release that energy. So spring. Sure. Next type is called elastic. Not elastic, I just said that. Electrical. electrical potential. So I'm just going to write electrical P. Electrical potential, that's energy stored in an electric field, so like lightning, a battery. Right, when you have lightning, there's electrical energy stored in the clouds and it gets released later. So it's electrical potential energy. The next type is kind of similar to that, is magnetic. Magnetic P. Magnetic potential energy. That's energy stored in a magnetic field, like a fridge magnet, MRI machine. I'm going to draw a horseshoe magnet. So it's basically energy stored in the magnetic field that objects create that could later be released. And then the last type we're going to look at is chemical potential. Chemical P for potential. That's energy stored in chemical bonds. Food, gasoline that has energy stored in it that could later be released. So say like you had an apple, or cherry the way I drew it. So if you had that food, right, if you ate it, that energy might later be released by your body as motion or heat or something like that. So last thing here, I'm just gonna, there's symbols for all the, there's gonna be a symbol for kinetic, little k, or sorry, uppercase K. Now there's gonna be a symbol for each of the potential energies, so I'm gonna write these to the left. Gravitational potential energy is gonna be UG. U is for potential, and then little g for gravitational. Then there's going to be potential, elastic potential, so UE, right? U is the potential, and then little e, elastic. And then electrical potential, I'm going to say UEC for electrical potential. And then UM for magnetic potential, and then UC for chemical potential. So those are going to be all kind of the abbreviations. So those are the types of energy. There are more technically, but these are the ones that we are going to look at. And again, most of them are types of potential energy, or energy that can be stored. So let's go to the next section. We're going to look at two types of energies more specifically. So those two, here we go. Those two types of energy are kinetic and gravitational potential. So there is an equation for calculating kinetic energy. Kinetic, just write it up here for space, energy, or the uppercase K. And it's this formula right down here. It's 1/2 mv squared. M is the mass. V in the v squared is velocity. So if you know the mass and velocity, you can calculate kinetic energy. There's also a formula for calculating gravitational potential energy. Gravitational potential energy, or U, like we wrote before, UG. So there's a formula for calculating that as well. So UG is going to be equal to M, the mass, times G. This is the acceleration due to gravity. And then H is a new one. Right, what that means, H is going to be the height that an object is above ground level. So if you have an object ground level, you have a cliff right here. If you have an object, how high it is off the ground is its H, and that determines how much energy is being stored as a result of that height. So there are lots of types of energy. There's two that they're going to have an explicit formula: kinetic and gravitational potential. So last thing, let's just see an example out with this. So take a second and see if you can solve it. Again, even if you can only solve part of it, that's much better than nothing. So take a second to do that before I go through it. Okay, so we have a book. It's not a book. Here you go. Book. Yep. Is moving across a frictionless ice at the top of a hill. Right? So this is kind of what's happening. It's not going off the cliff, but it is moving at the top. So we know a bunch of stuff about this. We know its mass. We know its velocity. We know its height above the ground. That's about it. I guess we could probably think about more. That's a good start. A is saying what types of energy does the block have? Well, the block is moving and it's raised above the ground. So it's going to have kinetic because it's moving. I'm just going to write uppercase K. And it's going to have UG because it is raised above the ground. So it's moving, it's raised above the ground, it has kinetic, and it also has some gravitational potential. B, what is the total energy of the block? The total energy, I never said total energy, but you can kind of assume that total energy just means all the energy added up together. So all that's going to be, in this case at least, it's just going to be UG and K together. That's what it is. So if we just calculate them, add them together, we will get the total. So that has a formula to it. Each one of these has a formula to it. So UG is equal to mgh, the mass, times g times the height. And then K has a formula to it as well. So we're just going to write the formula out. So we have those two, and now we're just going to write out what we got. So we have mass times g times h. So we know the mass. We know the mass is 0.1. We know g, little g on Earth. We assume this is on Earth, is 9.8. We know the height's 1,000. And then we know over here, we know 1/2. We know the mass. And we know v squared, so 5 squared. So what we're going to get is, if we do this out, is 981.25 J for joules. So we got 981.25 J for joules. So that's the problem. So again, not too bad, really just identifying energy and then doing a little bit of calculation with those two formulas. So that's about it for now. Make sure you have the notes down, make sure you have this problem, and that's it.